So, in today's video, we will be talking about how to complete the cube. So, we all know and love how to complete the square on quadratics, right? We start off with a simple quadratic, ax squared plus bx plus c is equal to 0. So, to complete the square, just move c to the right side by subtracting c from both sides, where we will get ax squared plus bx is equal to negative c. Now we could divide by a, so we get x squared plus b over a. X is equal to negative c over a. And you can go ahead and divide b over a by 2, whereas we will get x squared plus b over ax plus b over 2a squared. And to add it on both sides to maintain the equality. So now we can go ahead and complete the square on the left side since we have a perfect square now. And we can just go ahead and expand this. And now what we can do is just group the terms on the right hand side where we will get this. Now we just take the square root of both sides and we end up getting x is equal to b over 2a is equal to plus or minus the square root of b squared minus 4ac all over 2a. And we could just subtract b, where we get x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a, which is the quadratic formula. And how to complete the cube, or how do we do something like this for cubics? Well, the process is much more difficult and not as easy as a quadratic. So we have to start with a cubic, x cubed plus bx is equal to q, because that's how we can complete the square, or cubed. But we can't complete the square like we did with quadratics, and we can't complete the cube since we would need a perfect cube. So we would basically have to make some substitutions, such as involving new variables such as y, z, or alpha, or any variable of your choice. And what we will do is go ahead and solve for a formula. And with this, we will get x cubed plus px plus is equal to q plus something that maintains the equality. But what exactly do we do to complete the cube? We add y cubed, or any variable of your choice, and we express the x term, or px, as the volume of a rectangular prism. And we're also going to use a substitution where we have volume is equal to 3 x, y, z. So now we can do is solve for p by itself, where we will get p is equal to 3y, z. So we'll just leave it like this for now. And we could express the left-hand side as z, where we will get z cubed is equal to q plus y cubed. And we could either solve for z or y, but we will go ahead and get z by itself. And by doing so, we will get z is equal to p over 3y. So we will go ahead and plug that in, whereas we will get p over 3y cubed is equal to q plus y cubed, whereas we will get p cubed divided by 27y cubed is equal to q plus y cubed. And we're just going to multiply by y cubed, where we will get p cubed over 27, not y anymore, is equal to q y cubed plus y to the power of 6. And we could express this as a quadratic now by setting y cubed is equal to u and y to the power of 6 is equal to u squared. So we'll go ahead and just substitute y cubed and y to the power of 6 with u. We will get p cubed over 27 is equal to q u plus u squared, where we can go ahead and solve using the quadratic formula. So let's go ahead and erase the substitution, and we'll go ahead and solve for u, where we will get u is equal to minus q plus or minus the square root of q squared minus 4 times negative. If we move this to the right side, it's going to be negative. So that is going to be minus p cubed over 27. And a is just 1, so we will ignore it. So we just have that all divided by 2. And we will now replace it with y cubed, or we could just take the cube root at the same time, where we will get y is equal to the cube root of minus q plus or minus the square root of q squared minus 4 times negative p cubed over 27 all over 2. But now we can go ahead and simplify what's inside the cube root, whereas we will go ahead and get y is equal to the cube root of minus q over 2 plus or minus the square root of q squared over 4 minus or plus p cubed over 27. So we will go ahead and clear some of this space up and move some of the work around. Now we will go ahead and replace z with p over 3y, where we will get z is equal to p over 3 times the cube root of negative q over 2 plus the square root of q squared over 4 plus p cubed over 27. So that is what z is equal to. And now to find x, we will go ahead and use x plus y is equal to z. I will show y later, so just bear with me for now. And now that we could get x, we just go ahead and move y to the left side where we get z minus y, where we end up getting our solution to x for the cubic, which is x is equal to p, or first I should do the bottom part, 3 times the cube root of negative q over 2 plus or minus, or not plus or minus. We have to use plus or minus and minus. We can't use plus or minus because the solution will be wrong. Let's go ahead and do that. Q squared minus, or q squared over 2 plus p cubed over 27 minus a cube root of negative q over 2 plus the square root of q squared over 4 plus p cubed over 27. And that is our solution for x. So now that we have derived one method to solve it by completing the cube, we managed to get our solution, but it seems quite long. And as we can tell, that we had to complete the cube by adding y cubed and making the left-hand side into z, where we could solve for y using a quadratic and then going ahead and making the substitutions for y and z. And with that in mind, we can go ahead and use our solution. So let's go ahead and try a few examples out. So now we'll go ahead and look at the geometrical way this could be derived. So what we're going to do is start with x cubed being a cube with volume of x by x by x, or x cubed. We have x by x by x, or length times width times height. And that's the volume of our cube. But we're not going to write that down since we're trying to find x. And our px is going to be a rectangular prism with volume px. So px. And here we have to extend this cube out a distance 3y. Where we end up getting y, y, and y, which adds up to 3y. So we have to extend out 3y. And that basically gives us a new cube with side length and or length times width times height being x plus y. So we get a new cube with volume z. And we could break this cube up into separate shapes, including our original cube, which is going to be our first shape that we get. And we're also going to get a few rectangular prisms as well. And this has our original cube. And we also have a rectangular prism which has dimensions of x by y, and there's three of these, so we'll just write 3x. And we also have a rectangular prism again, but sideways. that has dimensions of x by x by y, where we have three of these as well. And finally, we have a small y cubed block with dimensions y by y by y. So with that, we can basically break up our cube and we basically get all these shapes. And if we rearrange our prisms properly, we will end up getting our cube back. So let's go ahead and try to place these rectangular prisms first. So they will go here, here, and they're going to occupy this space here. Not this little area though, that's for the cube. So this also has to be occupied by the y cubed block. And then we're going to look at the pink ones, where they are these ones that are flat. Go ahead and 1, 2, and it has to be on the top as well. It's going to be somewhere around here. And we have our square or our cube inside, which is like somewhere in the side here. So that's our proof for splitting it up into 8 different shapes. And if we rearrange what we have on the right, all of this, we could make a new shape with a volume of, let's just draw this down first. And this has to have the volume of 3x, y, z. But how do we for surely know that we will get this? It's by setting up our shapes such that we have that it has a length or height of 3x, a width of y, and a length of z. Or you can mix these up however you wish. So they're separated into 3 different parts where we get 3x and y and z. And when you rearrange this entire rectangle back and try to make a cube, you will basically see that you are missing the y cubed block. And that could have been drawn better to scale, but you get the point. Missing the y cubed block. Let's try to draw it better to see. So it is missing this here. I'm trying to erase this little area. So that's what it's missing. And we could see that it's missing it because if we basically replace the y cubed block again for this missing area, we will basically complete the cube, having gotten a new volume to set our px equal to. And we just have to complete the cube by adding y cubed. So we just have to do plus little y cubed block. And we end up completing the cube where we will end up getting full cube. So now that we have that, we add y cubed, which basically converts our equation to what I had shown earlier, which makes the equation x is equal to or x cubed plus px plus y cubed is equal to q plus y cubed. So that's the reason we had to add y cubed. And that's basically the reason we have our substitutions, where we had v is equal to 3xyz, and also where we got x plus y, because here we have x plus y, and it made z, which is all of this. So we get x plus y is equal to z, because we extended out our cube originally to make new cube with volume z cubed. So to find z, we just had to add x plus y because we're extending it out with x plus y. We get x plus y is equal to z, which is how we got our solution earlier algebraically. Let's go ahead and try a few examples and see how well our solution now works. We're not going to use the formula directly, rather we're going to use the process that we used to get the solution. So let's go ahead and see what our equation is going to tell us. So we're going to start off with a relatively simple one. So we're going to start off with x cubed plus 9x is equal to 26. So we will go ahead and add y cubed to both sides. So we have x cubed plus 9x plus y cubed is equal to 26 plus y cubed. Now we can go ahead and just set our volume equal to 9x because that is our rectangular prism. And we have volume is equal to 3xyz, so we could set that to our volume, where we will get or 9 is equal to 3yz. We could just isolate z, where we will get 3 over y. So with that, we can go ahead and see that we just have to convert the left side to bz. Cubed is equal to 26 plus y cubed, where we're going to replace z with 3 over y. Now all we can do is just distribute the cube, where we get 27 over y cubed, and that equals 26 plus y cubed, multiply by y cubed, where we get 27 is equal to 26 y cubed plus y to the power of 6. Now we can go ahead and set y to the power 6 equal to u squared, and y cubed to u, so we got 26u is equal to 27. And here we could simply see that our solution is u is equal to 1, because 1 squared is 1 and 26 times 1 is 1, which makes 27. So we only need one solution from our quadratic. Since we could get all two solutions, it's better to just use one solution, because we're only going to use one anyway. So now that we have u, we're going to go ahead and replace u with y cubed, where we will get y cubed is equal to 1, which is the same thing as y is equal to 1. Then we can go ahead and plug that into z, where we do get z is equal to 3. And now we could use our little equation here, x plus y equals z, where we get x plus 1 is equal to 3, where we get a simple two-step equation, or just a one-step equation, where we just have to subtract 1 from both sides to get x is equal to 2. Or if we go ahead and plug this into our cubic, it will be a true solution. So we have 2 cubed is equal to 8, and 9 times 2 is equal to 18. So 8 plus 18 is equal to 26, which is indeed satisfying our original cubic. So that is how we had to complete the cube to get our solution for x. And what would have happened if we directly just plugged in to our formula? How would it look? Let's go ahead and try that out, where we will see what difference it was rather than completing the cube. So just go ahead and plug into the formula that we had. So P is 9. Let's just write that down. P is equal to 9, and Q is equal to 26. Since it is written in the form x cubed plus px is equal to q. And here we will get x is equal to 9 over 3, which just cancels out, but we'll leave it like that for now, times the cube root of negative q over 2, which is negative 13, plus the square root of 26 squared, or 13 squared, since we're just using q over 2, because negative q over 2 is basically going to be represented here as negative q over 2 squared, since it's the same thing as q squared over 4. And once we solve for negative q over 2, we could just replace that here and square it, where we will get 169. And for p cubed, we will just get 729 over 27, where that becomes 27 plus 27. Because if we multiply 27 times 27, that gives us our perfect square of it being 729. So we get 27. And now what we can do is go ahead and add on to the equation, where our solution will give us, well, let's just solve for the cube root and then plug it in as the same thing later. So we're just going to solve for this cube root first. Negative 13 plus the square root of 169 plus 27, which is 186. No, 196. And there we see that the square root of 196 is 14. So we just write equals to the cube root of negative 13 plus 14, where we get the cube root of 1. So here we could just express the cube root of 1 as 1, where we now get x is equal to 3 over the cube root of 1, or just 1, which is going to just simplify down to 3, minus the whole cubic, or the cube root term. We'll just replace all of this here, but with a minus sign in front of it. So we get our solution, 3 minus 1, where we get x is equal to 2, which does indeed give us our original solution. So with that, we basically have our solution, and it works for any cubic, as we were able to tell. And we only used one example, so we can go ahead and try one more that doesn't have a full solution. So let's go ahead and try one more cubic out. And with that, we will go ahead and not directly use the solution, but rather we will go ahead and see how our quadratic behaves when we have a cubic with no whole solution. So let's start off with x cubed plus x is equal to 6. So we're going to go ahead and just complete the cube and do the same process we had earlier, which is just x cubed plus x plus y cubed is equal to 6 plus y cubed. And let's go ahead and set our volume equals to 1, or just simply x. Volume is equal to x. And we can just replace it with 3xyz, where we end up getting z is equal to 1 divided by 3y. Since p is equal to 1 and q is equal to 6. Or we could just plug it into the solution here, but we're going to complete the cube since that's what this video is mainly focusing on. And we are going to go ahead and just continue completing the cube. And we will get z cubed, which is just 1 over 27y cubed. We could just replace that up in the top. So we get 1 over 27y cubed, or 1 over 27y cubed is equal to 6 plus y cubed, where that will give us our whole quadratic. So we have 1 over 27 is equal to 6y cubed plus y to the power of 6. Let's go ahead and substitute u for y cubed in order to get our solution, where we will get 1 over 27 is equal to 6u plus u squared. And we can go ahead and use the quadratic formula to solve it, or complete the square, whichever one suits you or your preferences. So we'll just use the quadratic formula and we get u is equal to -6 plus or minus the square root of 36 plus 1 or 4 over 27. And 27 times 36 is 972. Plus 4 is going to give us -6 plus or minus the square root of 976 over 27 divided by 2. And that basically will give us our solution for u, where we could find y now by just taking the cube root of the entire expression. So we could just go ahead and simplify and make it look like this. We have to do -6 over 2 plus or minus the square root of 30 or 976 over 27, all divided by 4, since we're just fitting the 2 inside the square root. And just doing that, we will get 244, which is what's going to be inside of our square root. So let's go ahead and simplify. Plus or minus the square root of 244 divided by 27. And let's see if there's a factor of 3, where if we divide it by 3, we'll get 81 point, yeah, there's no factor of 3, so we can't simplify the cube root anymore. So with that, we now have what is y cubed, and we could see that if we plug it in for z, or yeah, z, we're going to get z is equal to 1 over 3 times the cube root of -3 plus, because we're choosing which one we want to use, so it's going to be plus the square root of 244 over 27. And we're also now going to find x by having z minus y. And with that, we can go ahead and see what our solution is going to be. We already have y here, which we don't need it on the screen anymore. Now, what we get is going to be x. X is equal to 1 over 3 times the cube root of negative 3 plus the square root of 244 over 27 minus the cube root of negative 3 plus the square root of 244 over 27, which should be our solution, and it is our solution because if we go ahead and plug in q and e into our equation, we're going to get the same solution. Let's go ahead and see what its decimal value is, and let's just copy and paste everything. And we see that our solution in its decimal form is going to be x is equal to 1.63436529,301, continuing. And if we go ahead and plug it into our cubic, we should get that it is equal to 6. Or if we subtract negative 6, it should be equal to 0. So let's go ahead and see if that is true. And if we go ahead and do that, we end up getting that the cube of it is 4.3656,347 plus everything we just said right now, plus 1.634365. And if we add just those up until those digits, we will get, let's see, we will get it is equal to 5.9999997, which is the same thing as it almost being equal to 6. So if we were to have used all our digits properly, we would have gotten 6. But since we're using the cubic formula, we're always going to get it as a solution like this, which looks quite messy, but that's the general solution to any depressed cubic, and we could go ahead and use it for other types of cubics as well, such as just moving p to the right side and such, but it all depends on how many solutions there are for the cubic. Let's go ahead and try one more, but without the without p being positive. So we'll go ahead and just test it out. But when p is positive, all you're doing is just changing the sign for negative. So let's go ahead and write an equation now where p is on the right side. We have x cubed is equal to 15x plus 4. And now we can go ahead and use the same method by subtracting 15x minus 15x is equal to 4. We just complete the cube now. Plus y cubed is equal to 4 plus y cubed. And since we're going to be using negative 15 for a volume, we're basically going to set it equal to negative 15x. And we're going to replace it here for 3xyz, where we're going to just solve for z immediately, where we just divide by 3y, where we get negative 5 over 3 over y, not 3y, it's already divided by y, over y. And now what we will go ahead and do is solve and replace the left side by z. So we get z cubed, which is equal to negative 125 over y cubed, where we just replace that up here, over y cubed. It's equal to 4 plus y cubed as well. And now what we will do is write our quadratic. So we just multiply by y cubed is equal to 4y cubed plus 6y, or y to the power 6, excuse me. And with that, we could just write our quadratic finally is equal to 4u plus u squared, where we could just solve using the quadratic formula. But let's move this to the right side, where we will get u squared plus 4u plus 125. Or we can automatically see that there are no real solutions that make this equation equal to 0, because the final, or c, is higher than every other number, meaning that it is above the x-axis. So we will have complex solutions, but we will go ahead and solve for y, whereas we will get x, or not x, u is equal to negative 4 plus or minus the square root of 16 minus 500. No, let's see, 4 times 125 is 500. And we divide that by 2. We get u is equal to negative 4 plus or minus the square root of negative 484, or we divide that by 2. And if we go ahead and simplify this, we get that it is negative 2 plus or minus the square root of negative 484 divided by 4, which is negative 121, which is the same thing as negative 2 plus or minus 11i. And we see that we have two complex solutions, which make the equation not true. Well, make the equation true, but not for our cubic. So what we have to do now is replace y. So we have, or u with y cubed, so we have y is equal to the cube root of negative 2 plus or minus 11i. And we basically now replace that with y for z, where we get z is equal to negative 5 divided by the cube root of negative 2 plus 11i. And now we just get x is equal to negative 5 divided by the cube root of negative 2 plus 11i, where we now end up getting minus the cube root of this again, minus 2 plus 11i, where now we have to find the solution using polar form. So I will teach that in a different video, but since we have this cubic with complex solutions on the inside, we will just go ahead and leave it as it is now, since that is our solution. So that's that. I have shown this example in a different video where I talk about the general solution to cubics. So that's why I used one of the same examples again. So that's why this may seem a little bit familiar. But thank you for watching and have a good day.